All right, everyone. My name is Jonathan LeBlanc. I'm the head of developer evangelism for North America at PayPal. And many of you might have been in the keynote with John Lunn and Damon Uglin yesterday, where they covered the login with PayPal mechanism and the seamless checkout product that's tied in a lot of the payment architecture within our systems. But I'm not going to give you a product talk today. It definitely won't be. I have been working in the industry, within the identity industry, for 6 years on different specs. I used to sit on the OpenID board within Yahoo, have contributed back to many of the specs that are out there, worked with OpenID, OAuth, XAuth, any sort of auth that's out there I've worked with at some point in the past. And what we're going to be looking at today is how a lot of this architecture works. Within the login with PayPal mechanism that you saw yesterday, what I love the most about it is that it's completely built off of open specifications. It's built and contributes back to the specifications that are out there. But there are a lot of specifications that came before it. There were a lot around the authentication aspects, the act of logging a person in, or the authorization aspects, the act of granting an application permission to use information on your behalf. And that's what we're going to look at today, how the specs that are around nowadays came from these real core places, from lessons that we learned over the years. And these are all things that we at PayPal have learned as we built out the specifications, as we contributed back to them, as we worked with the communities. But we'll take a look at all these open source initiatives that were looked at. And the ultimate decision when it comes down to it, from every company that I've ever seen implement this, whether it be Facebook from an open, more social login structure to PayPal with more of a concrete e-commerce type of feel. The ultimate questions have always been security versus usability. Ideally, you want to have a balance between the two. You want to find a structure that's not so complicated for developers that they don't want to implement your product, that it takes them too long and they necessarily won't do it. They'll just build it themselves. And at the same time, you don't want a completely insecure structure out there. You don't want to have something that people can't rely on. So that's really the ultimate decision that you have to make, is how to find a balance between the two. I've seen complete opposites on either end. I've seen very usable structures which were horribly built and that were completely insecure and just allowed massive data mining by outside structures. We don't want that. And at the same time, I've been on the opposite side where I was at companies where we touted how secure the system was and no one implemented on it, no one built anything on it. It was an abysmal failure. And that's why you have to make these decisions. So you have to find a good balance between the two. But when it really came down to it, these specs, these new specs that are out there, the ones that I love myself. I love working with them. I find them easy. I find them secure in what we're doing. I find that there's a lot of customization that you can do with it. But they came from real places. Now I can go on for the entire day talking about auth specifications and how we got to where we are today, but there are a couple of key points, a couple of key specs that led to what we have, what's available within the OpenID Connect and OAuth 2 specifications. And it all started probably about 5-6 years ago. I began working with a lot of login structures, the ability to essentially grant applications permission to do things on your behalf. And it probably started with a lot of the social integrations, social application development, which was so big at the time. MySpace, Facebook, they were all building application platforms, going into open social and such. But where it all began was with basic auth. You would just provide that information to an application, and you provide a real username, a real password to them to grant their application permission. So they would use your information as a mechanism for capturing your data and doing things on your behalf. Now, it was easy. It was quick because it was done via HTTP requests. But the biggest problem is, obviously, you're giving away your credentials. You're giving away your private information, and there's no way to take it back. The application has access to that. So the only way to change it is to change your password. Close out your account. Insecure backend. Easy structure, very usable, but insecure. And specification groups wanted to change this. They wanted something that was secure. They wanted something that was usable. And they wanted something that separated the act of logging in from the action of allowing applications to do things on your behalf, basically granting applications permissions. And that led to two specifications, OpenID and OAuth, which later became OAuth 1.0a. Now, these specifications were really nice in the fact that they used a tokenized system as opposed to username and password. They allowed you to have a series of keys, your consumer key and a consumer secret, which the application used to verify itself. You, as a user, what you would do is be able to give a grant to the application to capture your details or to use your details. And that grant could be revoked on the system. So let's say you're building out an application on a social application platform out there. You grant the application permission. You can go back to that root container that hosts the application and revoke its access. And since the application itself only has this little access token, think of it like a skeleton key for getting all your user information, what happened was that it no longer had access to your details. And it was great. And I probably integrated 500 to 1,000 different partners on these two systems. And it was a very harrowing experience for many, many people. Because the onus of encryption, the onus of actually making the system secure was on the developers. Hundreds of lines of code to implement these types of systems. And later on, it became even more complicated because some people wanted to combine the act of logging in with the action of granting permission. So OpenID had an extension on it called the hybrid auth extension, where they combined the two. So you took one really complicated spec, you took another really complicated spec, and you made an uber complicated spec. And it became very bad for a lot of people. So this is the point where we had a massive security system where it is great security, but not usable. And that's why OpenID itself was touted as the web's most successful failure. Because a lot of companies like Google and Yahoo who implemented it buried it deep in its documentation. But that led to a revision in what we have now and two really good specs that are out there, which I like, and they're very controversial. There are a lot of people that say that OAuth 2 is not a secure system. But a lot of the implementations, the issues that people have with it are very research level. Now, what happened with the specifications is OpenID was supposed to become OpenID Connect, have the auth mechanism, the authentication. OAuth 1 was supposed to become OAuth 2, essentially enabling a lot of the same features but making it more usable. It's not backwards compatible at all because what happened was instead of having the onus on the developer to implement everything, they took that away. No more libraries you had to include. All you're doing is making HTTPS requests. You make a redirection for the user to log in. You get back a code parameter. You use that code parameter, make an HTTPS post request out, and exchange for an access token. That's your skeleton key to access privileged information. Very easy concepts. Now, unfortunately, OpenID didn't keep up its end of the bargain. There were a lot of big companies that were behind it, and they couldn't agree on a lot of the specification differences on what it was supposed to be. So it really never materialized as a spec at the beginning. Around version 16 or 17 of the draft spec for OAuth 2, of the 30 some odd drafts that were created, Facebook took it on, and Facebook said this is going to be utilized for accessing our Open Graph protocol. Awesome. It was good and bad at the same time. They utilized it early on in a stage, which was probably not the best idea, because the spec was changing and they would fall out of alignment with the spec unless they kept continuing with it. But at the same time, they were using it for both authentication and authorization, which never really worked too well with OAuth 2. When you implemented the act of authentication or logging a person in, problem is that OAuth 2 didn't have any built-in mechanisms for user management. It was token revocation. So it became very difficult to revoke access to that token. Now, at the same time, if Facebook wouldn't have done that, spec wouldn't be as popular as it is today. So it's good and bad. Finally, OpenID Connect came around and said, oh, hey, we have something. We finally have something out there. And it actually answered a lot of the issues that were there. So it was built on top of the OAuth 2 specification. It had the same type of mechanisms in place. So at the basics, the core of OpenID Connect is OAuth 2. But it enhances it with a lot of user management endpoints, a lot of user management capabilities, like the act of logging out. You wouldn't believe how many partners I worked with that implemented on OAuth 2 where they requested the simple act of being able to log someone out. And then we have to say, well, OAuth 2 really doesn't support that as a specification. And that's where OpenID Connect became a beautiful, beautiful thing for us. It supported both authentication and authorization capabilities. So let's take a look at what this looks like in practice, how implementation of the specification can actually work from you as developers, as building on top of the platforms. There are a lot of companies out there that currently implement these specifications. Facebook does it, PayPal does it for their login with PayPal and the seamless checkout aspects. You have companies like Google and Yahoo all implementing versions of the specification. And it's actually pretty simple to use. So overall, what you're going to be doing, like I said, you start by redirecting the user to log in on, let's say, PayPal for the login with PayPal product. They'll log in, grant the application permission to access their details or do something on their behalf, and then they're passed back to a redirection URL, usually on the application itself, with a code parameter. And the code parameter can be used to exchange for an access token. That's our skeleton key for user data, for privileged user data. So when we take a look at it, what we're going to implement off the bat when we're making our first request, so the user comes to your site. When you first set up your application, so you'll go to, let's say, PayPal at devportal.x.com and create your application key. And this is the same for anyone out there. Everything I'm talking about right now is interchangeable with any company that's out there that's implementing the spec. So you're going to create your application and you're going to be given a consumer key and a consumer secret. These are going to be your mechanisms for creating your application. So in your application, when the user first hits the structure, hits your application, what you want to do is get that access token to start capturing their details. So you start by creating your redirection URL. You start by having your authorization endpoint, which is where you're going to forward the user on PayPal or whatever company out there. And you're going to pass through, as query string parameters, a couple of things. The client ID, which you can see, it can consider as a username almost on your application. You're going to pass through that. The scopes that you want to implement. So the scopes are essentially what data you want to capture about the user or what you want to do on the user's behalf. And then you're going to pass through things like the nonce, the state, redirect URI. Redirect URI ends up being where you get redirected to after the person logs in. And a response type, which in this case will always be code, because we want to get a code parameter back from the redirection. The code parameter is, think of it like a authorization grant. So a user has authorized it, and this is code saying that I can validate it for an access token. So then all you really need to do is redirect the user. So you redirect on PayPal, or you redirect on Facebook, or you redirect on Google. So the user's redirected, they log in, and they grant the application permission to use their information. Then they are passed through to the redirection URL. In the redirect URL, you're going to have a couple of query string parameters that are passed through, one being the code. The code's really what we care about here, because the code is going to allow us to exchange it for that access token. So now we're going to make an HTTPS post request back to the originating source, PayPal or whatever company. And you're going to pass through a couple of post parameters in the body. Your client ID and client secret, again, captured when you first created the application. You're going to pass through the code parameter, which can be obtained through the query string. And then the grant type, which should be authorization code in this case. Based on the spec, there's a lot of differences that can be here. This could be bearer token or different variations. But in this case, it'd be that. So then you make an HTTPS post request out, and you get this body back, this response body back, which contains a couple of things. The access token, what we need in order to grant or capture our privileged information. It's going to contain in most cases, a expiration time, how long the access token is valid for, a refresh token if the implementation supports refreshing a token. So in most implementations, you can perpetually refresh the access token as long as you want. And that's the information that we really care about. Now, spec to spec. This is based on our implementation, but there are a lot of differences. I've worked with maybe 8, 9 different implementations that are out there, and there's a couple of key differences between most of them. So when you first start working with the spec, you're going to notice, obviously, that endpoints are different. So going from company to company, your endpoints on your authorization code, on your access code endpoint, they're going to be different, obviously. Then your scopes. Scopes actually change depending on the company that you're working with. So some of them use what's called dynamic scoping. So when you're passing through the scope parameter and the scope body, essentially what you want to access from the user or do on the user's behalf, companies like Facebook out there use dynamic scoping. So you supply it in the code right there, and that allows you to grant that information. So it's all done code level right there. Other companies bind those scopes to the application. So when you create your application, that's where you define what scopes you want from the user. So you don't have to supply the information. Now, we at PayPal utilize a kind of a hybrid of this. So you specify your overall parameters that you might want from the user, basically your lofty goal of all the information, when you create the application. Then code level, you pass through the scope parameter, and that's going to be your subset of whatever that is, whether it's the whole or a subset. So you can modify that as you go along. And then, of course, the access token, using the access token in request. So once you have the access token, how do you use it to, for instance, call a user's profile and get back profile information, or friendship information, or do things on the user's behalf? Well, in some cases, you pass the access token through a query string parameter in a HTTPS GET request. Sometimes, in our case, you'll pass the information through the headers. So all that will change depending on your implementation. Spec to spec, it's really not that much different. So you can take an existing spec from any company that's out there and modify it within probably 10, 15 minutes to work with another company. Very open and easy to use. So when we're actually talking about this, now that we have our access token, we can utilize it to start getting our information, right? We can use it to collect user information. We can use it to do things, do privileged things. But the way that it's typically used nowadays comes from the social login days. So within the social realm, you use it to capture information about a user's profile, friendships, or profile information, or post to a wall or a comment stream or something. An existing mechanism that's already there, that the user can do themselves. You know, it's simple, it's easy, but it's boring. It's how access tokens are utilized nowadays. They're just there to access data. But the real question is, why would you want to restrict it? You have this application that the user has granted permission to because they want something from it. They want the application to be able to collect its information, to utilize it, to personalize their experience, make their life easier. That's what an access token is supposed to be. That's what an access token should be in an implementation. Now, in the keynote yesterday, you heard about seamless checkout, where we're using our login with PayPal mechanism as a method to allow you to log out a user, or basically check out a user, pay for products without having the user log in again. So what we decided to do with the access token was we said, well, we can use it to capture a user's profile information, but of course we're going to do that. It allows you to get concrete user information about a person as opposed to a socialized or perceived login information. But why stop there? There's a lot more we can do. We have this entire product suite that's out there where a user has to log in again. So why won't we enhance those products? And that's exactly what we did. We took an access token, and passing the access token through our existing systems, you no longer have to log out at checkout, making it an easy transition for you to simply pass the access token, and the user is just a one-click flow. And if you've done any usability studies on this, you'll know the more screens you put in front of a user at checkout, the higher the drop-off rate. The more that a user is just going to leave and ignore that. All right, so I'm going to leave you off with a couple of things. With the code that's really interesting to look at, if you take a look at my GitHub account, github.com/jcleblanc/OAuth, that's the repository that I have where there's a bunch of different implementations of OAuth to OAuth 1. So if you're really interested in the specification, take a look at how some of those code samples differ. There are a whole bunch of different companies out there, not just the PayPal stuff. You can see the variations in the spec, everything I was talking about. Then, if you want to take a look at specific OAuth 2 and OpenID Connect implementations, we have them up on the PayPal GitHub account under the old name of PayPal Access, soon to be, well, currently login with PayPal. Then, if you want to take a look at login with PayPal itself, the mechanisms that we're using, completely built off of open source, that's what we have available at the bit.ly URL. I'll give a link out to the slideshare at the end so if you want to download it. All right, so the last thing I want to mention, and John had mentioned this yesterday, but we are having a series of battle hacks for good within PayPal. These are things that I truly believe in, and I've done a lot of hackathons in the past. And I feel that this can be something that's really good because we're trying to support at the same time the social good aspects and also promoting a potential startup. So people with a good idea, we have our first implementation of the battle hack in Berlin and then coming to Seattle next. If you go to battlehack.org, you can see all about that. And also, our team, if you want to have an effect on change on these open source specifications, if you want to have a change at PayPal, we're here to really push these open source standards and to make things different at the company. We want to make it open for developers and try to make it a better implementation for everyone. Improve our products, improve our developer sentiment. So we are hiring. Within North America, my team is hiring. We're looking for new evangelists to grumble about the internals of PayPal, to be critical about the products and improve the products. So come up and see me if you're interested in that. So thank you very much, everyone. The presentation is available on this bit.ly URL, and thank you for joining me.